All right, welcome back, everybody. Hopefully, you didn't have too many problems with the first two leavening agents that we talked about, mechanical leaveners and biological leaveners. Today, we're going to kind of get into the meat of what our real leavening agents are going to be, and the ones we're going to probably spend the most time talking about. And those are our chemical leavening agents. I will get the presentation going in just a sec if my computer cooperates. There we go. All right, so at the bottom of the screen, you can see two little pictures there. You can see a box of baking soda and a box of baking powder. Not to ruin the ending, but those are probably our two most common chemical leavening agents. What chemical leavening agents are chemicals that we add to doughs and batters that undergo what we call a decomposition reaction, which means that they're breaking apart, and neutralization reactions, which means that two things are kind of canceling each other out. And the big thing about a chemical leavener is that they all produce the same things. They produce either carbon dioxide, CO2, or they produce CO2 and water vapor at the same time. And like I said, the two big leavening agents that you have all seen before are baking soda and baking powder. And they are a little bit different, and we will get into the mechanics and reactions of how they work quite a ways from now, but we will kind of get into just a little bit of how they work. Chemical leavening agents are most commonly used for when we in baking make something called a quick bread. You will see a link right up here for quick breads, and I'm going to link that to a YouTube video of a woman who does a really good job of just kind of explaining what they are and the two differences of the ways that you can make quick breads. But realistically, a quick bread is essentially a bread that happens and can be made really quickly. If you normally make a loaf of bread using yeast, yeast takes a really long time to kind of do its thing and produce its bubbles to help lift the bread up. Quick breads are breads that are leavened with anything other than yeast or eggs. And that's because the action for a baking soda or a baking powder is really quick and immediate in its carbon dioxide production, and it helps give you the lift that you're looking for in your baked good without having to wait for 2 hours for your yeast to activate and kind of do their thing. So you're going to see this used in things like brownies, cookies, banana bread, zucchini bread, biscuits, muffins, pancakes, scones, all that jazz. Anything that you probably have made that wasn't a loaf of true bread is going to be um, made with one of those chemical leavening agents. The way that they work, baking soda and baking powder, is that they themselves are acids and bases. And I'm confident that you have heard that term before. So we're going to kind of get into what acids and bases are because we need to know how they work first before we can talk about the reactions between baking soda and baking powder. What acids are and what makes them acidic is that they are chemicals that have a hydrogen in their chemical formula that is able to break away and go to another compound. And those hydrogens are kind of the things that end up being responsible for the production of the carbon dioxide that we will see later on when we talk about the actual chemical reactions. Bases are chemicals that can take the hydrogen ion from the acid. And so acids and bases are kind of counterparts to each other. They balance each other off. And when we use the term neutralization, a neutralization is when an acid is canceled out with a base. So they act kind of in opposite of each other. Okay? We're going to go over a couple properties of acids, a couple properties of bases, and then look at some of the acids that you commonly find in food. All right, acids tend to have a pH lower than 7, and in our next set of notes, we'll go over the pH scale in more detail, but acids have a pH that is less than 7. Acids tend to be sour tasting when you get them in your mouth. So like if you've ever had a Sour Patch Kid, Sour Patch Kids are coated in citric acid, and the citric acid gives it its sour flavor. If you remember when we did our taste test for sour, or for acid, I'm sorry, let me back up. If we did our taste test on the tongue for sour, what I did was I mixed citric acid in there, and a lot of foods have acids in them to kind of round out their flavor. If you have an acid in a high enough concentration, they actually can react with metals and they form hydrogen gas if you give them time to react. And you know this, they will prevent bacteria from growing when they're in a high enough concentration. So when they make things like canned goods, like peaches and corn and all that kind of stuff, they have to have a high enough acid concentration. Otherwise, you can end up with things growing in there like the Clostridium botulinum that we talked about, which is botulism, and that's the stuff that can poison you and kill you pretty quickly. So having the right amount of acid in there is super duper important. Most foods that you encounter are going to be acidic. Along with your lesson today, I'm going to attach a list of different foods and their pHs. Remember, if it has a pH less than 7, it is going to be an acid. And the vast majority of the things on that list are acidic. So you will see, it's kind of shocking to see how many foods are acidic. All right, bases. On the other hand, the counterpart to acids tend to have a pH above 7. 7 on the pH scale is where water sits, and water is considered neutral. Water is the perfect balance of acid and base. So it has a pH of 7. Anything above a pH of 7 is considered basic. Bases tend to be more on the bitter side of things, and they tend to be things like cleaning products. So if we're talking about like soap, I know that when I was a naughty kid, I apparently picked up lying when I was like kindergarten, and I lied to my mom. I got soap in my mouth, and it was not pleasant. It is very bitter tasting. Cleaning products tend to kind of all be in the basic range, and I would not recommend tasting those. Bases also tend to be slippery to the touch. So if you get them on your fingers like soap, they're a little bit slippery to the touch as well for you. And I guess that would be the biggest thing to note of that. When you look at a chemical formula, there are a couple things that you can do that will give you a hint about whether a chemical is an acid or a base. And this is something I expect you to kind of be able to do. So if you have questions, be ready for the meat if you aren't 100% sure. So for our acids, a lot of times with acids, the chemical formula starts with an H. So it'll be like HCl or HNO3, but the chemical formula leads with an H. The other thing you will see is that the chemical formula ends in COOH, and that, if you remember, is our friend the carboxylic acid. So the carboxylic acid is the C. Ooh, that's a terrible C. My first time drawing on here. It's a C with the double bonded O to the OH. I need to practice this, guys. Holy moly. So that carboxylic acid here is, shocker, an acid. And it's this little H here that ends up coming off. Okay. Bases. Their chemical formulas tend to end in, let's get rid of the red here, in an OH. So if you see something like NaOH, oof, the writing needs to be worked on a little bit there. NaOH, that is going to be a base. And if you see something with NH and then the X is not an actual chemical, it's a number. So like NH2, NH3, something like that is going to be a base. Okay. You do not need to write this stuff down, but I just want to give you kind of, if you ever looked at an ingredient label, you may see some of these on there, and I want to let you know what they are. Now you can see on here, we have a carboxylic acid here and a carboxylic acid here. So in the case of this chemical called tartaric acid, it actually has 2 places where it can be an acid on there. And that is typically used in jams, meringues, baking powder, candies, and sweets. And it does all sorts of stuff. It keeps the taste sour. It adds structure. It prevents sugar crystallization, which means it keeps things from getting grainy. And it's a leavener. Citric acid, the big one, pardon me, that you use a lot, has a carboxylic acid right here, and right here. So it has the ability to give away 3 H's, 1, 2, 3 of them. And so it is very acidic potentially, and they use it a lot, for sour candy. It's also in citrus fruit, hence the name citric acid, and they use it a lot in like canned salsa and stuff like that to bring the pH down and make it safe so that bacteria can't grow. Okay. Another is fumaric acid, carboxylic acid group right here and right here. And they use fumaric acid a lot in like biscuit and cake mixes to give it a sour flavor. It's a leavening agent, but also it's a preservative to keep things from kind of going bad. The other acid that I'm guessing you probably have seen more often than not is acetic acid, which is just a fancy name for vinegar. Vinegar has one carboxylic acid group right here. They use vinegar most of the time for pickles and salad dressings, and it works as a great preserving agent. And then phosphoric acid has an acidic hydrogen right here, and right here, and right here. Now you may say to yourself, hey, Mrs. Ademeyer, you said that if it has an OH, that means that it's a base. However, if you look at the formula for phosphoric acid, it is H3PO, 4. So it starts off with the hydrogens there. Phosphoric acid is used a lot in soft drinks and sodas, and you'll see it to add sour, because a lot of times if you have something that's just sweet and there's no sour flavor, it actually tastes really flat. So when they make candies and suckers and things like that, even though you don't think you'd want to have a sour flavor when you're making, let's say, like watermelon flavored sucker, what they do is they add in a little bit of acid, whether it's citric acid or something like that, to round out the flavor so it just doesn't taste just sweet. All right. Again, these last two slides you don't need to know, but they are kind of a little bit interesting. So what I need you to do is, if you did not get the notes for these first couple slides, you're going to want to do that. And then you need to go back and talk about the quick breads video. I'm sorry, not talk about, but go back and watch that quick breads video, and she does a really good job of explaining that stuff. All right. Sound good? If you have any questions, we can talk again and meet. Otherwise, good luck.